Okay, hello. This is section 8.2 series. Okay, so introductions. Series is the summation of the terms in sequence. So we are adding up. The series is used to be the approximate function. There are two complicated to have a simple formula. And series are also instrumental in calculating approximations of numbers like a pi and e. So infinite series. So this is kind of numbers to adding the terms together. So we call the finite series. And then the infinite series means there's no n numbers, it's continuously going on. So partial sum. So the only way that we can get is a partial sum. So partial sum means sum of the first term is a sub 1 is a s sub 1, and s sub 2 means adding two first two terms. S sub 3 means adding three first three terms, and n means adding the first term through the all the way to the nth terms. So complete the following. So write the sequence that is first of five odd natural numbers. These numbers are from the one, right? So one, and sorry, 1, 3, and 5, and 7, and 9. And then B, write the series, which means you add them up. And then what will be a sum, which is add them up, you get to 25. Alright, let's look at the example 2, which is, so let's calculate the first five terms in each sequence. Okay, so first of all, we have to find the first term, which is probably 1, which is 1. Second term, probably 2, which is a 4. Third term, probably 3, which is a 7. Fourth term, probably 4, which is 10. 3. And then fifth term, probably 5, which is the 13, okay? So now what is the S of fifth means? Adding the first, second, third, fourth, fifth together, which is 1 plus 4 plus 7 plus 10 plus 13, which come out as 35. So you can do that for the next one. So A sub 1 means 1 squared plus 2 come out as 3. A sub 2 means 2 squared plus 2, which is 6. A sub 3 is 3 squared plus 2, 11. A sub 4, 18. Now S sub 5 means adding all four first five terms together, which is 3 plus 6 plus 11 plus 18 plus 27, come out as 65. Okay, example 3. The infinite series given by Ln of 2 is equal to 1 minus half plus 1/3 minus 1/4, like that. Can be used as an estimate of Ln2. Approximate Ln2 by defining a sum of the first four terms. So first four term means you have to using the a sub 1 plus a sub 2, a sub 3, a sub 4, which is 1 minus 1/2 plus 1/3 minus 1/4. So it's about 7 over 12, approximately 0.5833. Now, use the technology to approximate the Ln2 by summing the first 50 terms. So S of 50 means that you can get a pattern of 1 minus half plus 1/3 minus 1/4 plus 1/5 minus 1/6 all the way to the last term, which is I think it looks like negative. I think it's going to be negative term. Negative of 1 over 50, which is about 0.6832, okay? And then n of 2 that compare is 0.693147. Go on, right? Yeah, so very similar to, right? Okay, let's look at the next page, okay? And then we're going to talk about the special series, which is arithmetic series first, okay? So arithmetic series means we can kind of make that as formulas. So of course, S sub n means adding all the n terms together from the first, which this is the formulas we can use. All right, so use the formula to sum of the arithmetic series, okay? So in order to find the sum, but we need to find the n first, okay? So I don't know, I can say this is the nth term, right? Because we don't know how many terms are there. So S sub n is actually n times a1 plus an to the 2. That's a formula, right? So I need to find the a sub n, which is the formula is a sub 1 plus n minus 1 times d. So a sub n is 28, a sub 1 is 1, which is, we don't know about n, but I know the common difference is 4 minus 1, which is a 3. So I am solving for n, okay? So 1 plus 3n minus 3 at 3, oh no, hold on a second. So 2 and 8 is 3n minus 2 at 2 both sides. So n is a 10 this time, okay? So I'm looking for s sub 10, which is 10 times a sub 1, a sub 10 over 2. But 10 times a sub 1 is 1, a sub 10 is 28 over 2, and then simplify, you got 145, okay? So that's a sum. Even though we don't know the number between, but we still can find the sum of the every numbers in the sequence, okay? All right, example 5. A person has a starting annual salary of the 40,000 and received the 2,500 raise each year. So calculate the amount earned over 10 years. Okay? So first of all, we need to know how much he's gonna get 10 years. Okay, so first year it was a 40,000, and then each year 2,500 raise. Okay, so a sub n, which is a sub 1 plus n minus 1 times d. So a sub, we're looking for this formula, so which is a starting of 40,000 and minus 1 for d is a 2,500. Especially we're looking for the work for 10 years, right? 10 years raises, and then 10 minus 1 times 2,500. So when you simplify, so 10 years is going to be 62,500. Now we can find the S sub n, which is n of a1 plus an over 2. But we're looking for the sum of the wage of the 10 years, right? So 10 of a1 plus 8 sub 10 over 2. And then 10 of a sub 1 was a 40,000. And then it becomes 62,500 over 2. So it becomes 512,500. That's actually the money they make for 10 years. And then you can verify the calculator. So if you use S sub 10, yeah, I got 112 and 500, okay? All right, number 6. Sum of the arithmetic series is 12 terms is 378, and then a sub 12 is 59. Find the a sub 1. So we're using the sum formula, right? So n of a1 plus n over 2, which is, we know the a sub 12, right? Because that's the sum of the 12 is 378. So 12 a1 and then a12 over 2, right? But we know the s of 12, which is 378. And then 2 goes 12 6 times, the 6 of, but a1 we don't know, but a sub 12 is a 59, right? Then we are solving for a sub 1, okay? So divide by 6 both sides, I got 3 a1 plus 59, subtract 59 both sides, a1 equal to 4, okay? So you can use the sum formula of arithmetic to find any missing things, okay? Now, geometric series. Geometry means actually the increasing by multiplying, right? Or dividing, right? So this is a formula for that. So approximate the sum of for each n. So we have to use this formula for the s of 4, which is a sub 1 is 1 times 1 plus, and the odd is a negative 1/3 this case, isn't it? So negative 1/3 to the fourth power over 1 minus of negative 1/3. And then calculate that is 20 over 27. It's about 0.740741. Now s sub 8 starting at 1, same thing. It's exactly the same except the power is 8. 1 minus of negative 1/3. And then becomes 1640 over 2187, about 0.749886. S sub 12. 1 times 1 minus negative 1/3 to the 12th power over 1 minus of negative 1/3 becomes 0.74 and then 9, right? Alright, same as here too. So S sub 3, 715, right? Which is A sub 1 is a 2 of 1 minus of is R is negative 2, right? So negative 2 to the third power over 1 minus negative 2. I got about 6. And S sub 7, which is 2 times 1 minus of negative 2 to the 7th power over 1 minus negative 2. I got about negative 6. And S sub 15 is 2 times 1 minus of negative 2 to the 15th power over 1 minus negative 2, which is 21,846. Alright, let's look at the annuity. Okay, so any sequence of the deposit made an equal period of the time. After n years, the amount is given by that. So that's the formula we have here. So suppose that a 20-year-old worker deposits 1,500 into account at the end of each year until age 65. If the interest rate is at 88%, find the future value of the annuity. Okay, so we have to actually subtract to find the n. So n will be 65 subtract 20. So these people will work for 45 years, right? So 45 years, how much? So from the 1,500 every year with the 8% to the power of the 45 years and subtract 1 over interest rate. And then adds 579,758.43. Okay, so this is the money that he saved for 45 years. Not bad, right? For the 1,500s every year. Okay, and then the sum of the infinite geometry series. Okay, so this time there's a way that we can actually define the sum of the infinity, which looks like impossible, but that is, okay? But there's a condition. So R must be between so the R should be between the 1 and negative 1, okay? Yeah, otherwise you cannot find it. So A sub 1 is a 4. R is 1 over 4, which is between negative 1 and 1, right? Yeah, so we can find the sum with the A sub 1, 4, 1 minus R 1/4. And then if you multiply for both sides, I got 16 over 4 minus 1, which is 16 over 3, which is sum of the 5 1/3. Okay, let's talk about summation notation. Summation notation is usually written as series efficiently. The symbol sigma, the uppercase Greek letter sigma, indicates the sum. So this is a lower limit, this is the upper limit, and then all the way to from the 1. Then don't forget that there's a middle numbers and up to n. Letter K is called the index of summation. So number 1 and n represent the subscripts of the first and the last term of the series. They are called the lower limit and upper limit of the summation respectively. Okay. All right. Let's look at the next page. Okay. So the property of the summation notation means if the C is just the scalar, you can pull it out too. And then also if there's a sum of the two sequence, you can split them out to two different segments. Subtraction you also can do too. And then C is a constant, so you just need to multiply how many of them as the number. And then when you have a power k, which is a variable, and you got this, and the square, you got this, okay? So evaluate each series, okay? So which means this case means you're adding the 4 the 5 times. Which means it's a k equal to 1, still 4, k equal to 2, k equal to 3, k equal to 4, k equal to 5, and come out as a 20. All right. This one means what? Now we have to figure out the k equal to 1. You get 2 times 1 minus 1. k equal to 2. You got 2 times 2 minus 1. K equal to 3. 2 times 3 minus 1. K equal to 4. 2 times 4 minus 1. K equal to 5. 2 times 5 minus 1. And k equal to 6. And then you got 2 times 6 minus 1. So which means you got 1 plus 3 plus 5 plus 7 plus 9 plus 11, which come out as a 36. All right, third one. Okay, this one is a k equal to 1, which is a 1 cube plus k equal to 2, 2 cube plus k equal to 3, 3 cube plus k equal to 4, now the 4 cube, okay? So which is 1 plus 8 plus 27 plus 64. We come out as 100. All right, write the series and summation notation. So now you have to look at the pattern. So as a sum, let's say k is from the, so this was starting from the 2, right? So I want to say 2 up to 6, right? So that's number changing, right? You can do that too. You don't have to say k always equal to 1 or 0, okay? And then what happened is 3 stays, okay? So constant, just constant. And the power is always 2, right? But except the base, which is okay, right? And then you will see the plug in 2, 3 over 2 square, plug in 3, 3 over 3 square, right? So yeah, that's how you can find the formulas, okay? All right, next page. Same thing here too. So the first number is starting from the 3, 4, 5, 6 up to 8. Yeah? So I want to say 3. And then also what I noticed, okay, numerator always one more than. So if I say k and this is k plus 1, we can do that too. All right, example 12. We write each summation so that the indexes start with the n equal to 1 this time. Okay, so we can do this too. So instead of this, I want to say k equal to 1, which is 6, 7, 8, 9, 10, 11. So there are 6 terms. And then you start with a k equal to 6. So in order to k equal to 6, you should get the k plus 5 to get 6, okay? Same here too, okay? Sigma k equal to 1, but between the 6 and 9, there are 7. Okay, and then you got the 9, but in order to get a 9 from the 1, you have to say k plus 8 plus 6. Okay, use the property of the summation notation to find each term, for example, 13. So this time is c is just constant. Do you remember the n times c? So 30 times 4, and then 120, that's all. The next page, and this is the same as 7 times of sigma k equal to 1 to 24k. And also this is the same as n times n plus 1 over 2. And then n is actually the 24. So 24 plus 1 over 2. You got actually the 2,100. Same thing here too. I'm going to use a property, which means split them up. I put down as sigma k equal to 1 to 16, 2k plus sigma k equal to 1 to 16, 3. And then there's a formula for the case over x. And then pull out the 2 of the sigma k equal to 1 to 16k. And then this is the same as 16 times 3, right? And then n is a 16. So 16 over 16 plus 1 times 16 plus 2 over 6 minus 2 times. Now it is n times n plus 1 over 2, right? And this is a 48. And then when you compute this, I got a 16 minus 2 times. This time is 16 times 16 plus 1 over 2 and 48. And then I got a 16 minus 272 plus 48. And then come out as a 1,136. Alrighty, that's for the 8.2. Thank you.